Well, I have learned that even if you are not a master in mathematics or in science, you are still able to grasp the essence and the basic ideas.
Hello and welcome to Living Proof, the joint podcast between maths.org and the Isaac Newton Institute for Mathematical Sciences. I'm Rachel Thomas. The person you've just heard is Céline Broeckaert, and she's talking, believe it or not, about quantum physics. Yes, that's that famously difficult theory which celebrates its 100th birthday this year. Céline knows what she's talking about. She isn't a physicist. In fact, she's a Romance languages scholar, a playwright and an author. And she also co-founded something called Film Pact, which uses documentary film as a tool for social change and ecological awareness. But Céline has written a book about quantum physics called Why Nobody Understands Quantum Physics and Everyone Needs to Know Something About It. Céline's written the book together with her husband, and that is Frank Verstraete, who is a physicist. He's the Lee Trapnell Professor of Quantum Physics at the University of Cambridge, and he's one of the leading researchers in the world on quantum physics. He's currently co-organising a research program here at the Isaac Newton Institute called Quantum Field Theory with Boundaries, Impurities and Defects. My colleague Marion Freiberger took the opportunity to talk to both Céline and Frank, and it's really fun seeing those two worlds come together. They chatted about what gave them the idea to write the book in the first place, what the experience of writing the book together was like, and particularly what their different perspectives brought to the project. Marianne started out by asking Céline to tell us more about her background.
I am not a scientist at all, but have more an artistic, cultural background. I studied stage directing, so theater stage directing, and then languages, Italian, French, literature. And I worked mostly in theater for documentary films. And the main thread through all the things that I've done is trying to make difficult topics more accessible for a broader audience. That can be through theater, through books, through documentary film, or whatever, more an artistic, through artistic, creative ways, trying to make difficult topics more accessible. That's actually, in essence, what I do.
And what kind of topics have you worked on before in the past?
When I was working with documentary films, it was very broad a range of topics. Could be unaccompanied minors, refugees, ecological aspects. I played for a couple of years a monologue that I have written myself, and I played also myself, that was on intimacy during cancer, because I noticed that there is also a huge taboo on this topic. And by playing it in hospitals, I tried to make people talk about it and to make them feel that, okay, they're not the only ones who are struggling with these issues. And now, yes, then Frank a couple of years ago came with this fantastic, exciting idea to write a book on quantum physics together. So it was, again, another way for me to step out of my comfort zone and to do this together. But I think, yes, the fact that we did it together, I'm actually the target audience. So that made it so interesting, but maybe that's a question for later.
Yeah. So Frank, so what's your background?
Yeah, so I'm a professor of quantum physics, so the Lee Trapnell Professor of Quantum Physics at the University of Cambridge. And I have been working on quantum physics for my whole life.
Right. Okay. So now you've written this book together, which is called Why Nobody Understands Quantum Physics.
And the entire title is, and everyone should know something about it.
Yeah, exactly. So, okay, so tell me, so you two come from these very different backgrounds, even though you say, Céline, that you kind of work in bringing difficult concepts across to people. But how did you come up with the idea to do this book together?
Yeah, so in Belgium I got some kind of a prize, and during the speech that I had to give when I received this prize from the Belgian king, actually, I said something about the fact that I did not understand that people would spend an incredible amount of time in reading a book of War and Peace, okay, of Tolstoy, which is extremely complicated. You have to kind of keep track of lists of who is who and all this, but people do this. They find this with pleasure, and that I didn't understand that they would not spend a similar amount of time to learn a little bit about physics, which is in some sense even a greater masterpiece of nature. And that had triggered something with an editor, and they came to me and said, you have to write a book on this. And this was actually during COVID. I said, how difficult can it be? I have so much time now during COVID. Let me write a book because I understand very well what it's about. And I got completely stuck. So I started writing, and I was extremely excited. I thought what I was doing was fantastic. And then my daughter read this, and she really was really laughing when you said, Papa, this is exactly the opposite of how you should do it. It's completely useless. Nobody will understand anything. And actually, I was telling this story to my wife Céline. At that point, we were not a couple yet, and for one other reason, Céline started asking exactly the right questions. So she started asking like, why are you doing this, and how do you set this up, and all these different questions. And I got actually, I found this fantastic. As a scientist, we are extremely susceptible or sensitive to people that ask good questions. And when people ask good questions, it means that they understand it. That's what we want. No? As a scientist, it's the difficulty in our lives is not to solve questions, it's to ask the right questions. And if an outsider asked the right question, this was exactly what I should have done in the book. That's how we decided actually, and how I asked you to write the book together. And this is also how the whole process went. It's like I basically sketched somehow what I want to say, and the book is really like a story about the quantum physics, like working physicists understand it and want to understand and think what is important, but then completely interpreted by the language of Céline. And this is it's something that was, I completely underestimated this, what a gap there is between understanding something and being able to make it understandable and appealing to a wider public.
So can you give me an example of like a kind of question, Céline, that you might have asked that would have been a question that you wouldn't have asked in the same way, Frank, and that somehow helped with this process of elucidating this kind of complex theory?
Yeah, I would say so the question is that everything has to be very tangible. Okay, so you must be able to picture it, so to have an image of what is actually going. So we start the book actually somewhere in the beginning of the Age of the Enlightenment, when people started doing experiments with falling objects, very counterintuitive things, that something light and something heavy can fall equally fast. This is something that we all feel this should not be true, but it is true, and this is what Céline was able to make very plastic, so very explicit. These are kind of the paradoxes that you have to try to understand, and that the whole story of quantum physics is very much like this. And this is what Céline was able to do, to make things very
tangible.
Because
quantum physics is a very abstract theory. And that made it also very exciting for me. Well, difficult and exciting at the same time, because I had a lot of material to play with and to try to find the right metaphors to make these very abstract ideas more tangible and more visual. And of course, I had to ask sometimes 100 times the same question for me to more or less understand what Frank was trying to say. And at a certain point, he also said, Van, you have to stop trying to understand it. At a certain point, you just have to accept that you cannot understand it. After the years, they developed a certain intuition for this very difficult.
Yeah, as a scientist.
As a scientist, yes. And so I had to stop, try to understand everything and just accept this is how it is and try to make it tangible and that's it. But that was quite an exercise of finding the right balance between being clear and between not too abstract and yeah.
So it was actually a very long process. So it's not something that we did in a few months. It took actually more than a year in ping-ponging back and forth. Mm-hmm. and basically like the first chapters, I think we wrote them 3 times. No, so the first time, and then we threw it away everything, and then the second time. So it was, mm-hmm. but it was. I think for me it was a wonderful experience to also kind of stand back and think a little bit about why is it what you're doing, or this whole physics. What is now the real impact? What are the really important things? What are the really important concepts that everybody should know? What kind of things in quantum physics should everybody know, such that they would appreciate more the incredible beauty of this world. And this is the things that drive us. And that's why it's so important to work with somebody that is an outsider, like Céline says, to somebody that is the audience of the book, because the sensitivities of what we as scientists have are very different than what the general public has. If we write a book or a textbook, the primary goal is such that people would exactly understand everything we would say, and the students would be able to reproduce. When people read a popular science book, that's not at all the goal to become a scientist. They want to get a feeling, they want to have some intuition, they want to kind of experience a little bit of the beauty, they also want to be surprised. And that's a very different way, that's a very different thing than writing a textbook.
Yeah, so on one hand, we wanted the book to be right. Everything that's in it is, of course, theoretically correct, but we also wanted it to be beautiful. That's why I wrote, but these are not translated in the English translation. I wrote all kind of little poems, funny little poems, and I was looking for funny anecdotes about all these main characters, Pauli, Fermi, Allen Bohr, Einstein, whatever, just to stimulate the reader to continue reading. So we even explain it in the beginning. If there are parts that seem too difficult, you can easily switch them and continue a little bit later. But yeah, we didn't want to take, or Frank maybe didn't want to take himself too serious. This is just what it is, but in the first place, it has to be a nice experience to read it.
Yeah. So we were. Yeah, sorry. So maybe in connection to this, what the image that we had very strongly was based on a book that we both had read a long time ago from Patrick Suskind, and it's a book that is called The Perfume. The Perfume, and it's a book that is about, okay, it's a story about some person that smells extremely well, but if you have read this book, suddenly there's a whole new world that opens. You smell things that you have never smelled before, and that was exactly a bit the goal that we had with this book, that a reader, even if it's not important that you fully follow everything or understand everything, but after you have read this book, that you will see things that you didn't see before, that there will kind of, you will start asking questions about things that you never asked before. Okay, like very simple things. Why is matter hard? Why, if I push on this table, why is my finger kind of be pushed back? This has nothing to do with forces. It has to do with symmetries. It has to do with something that's called the Pauli exclusion principle, something extremely strange. It has to do with group theory. Before we talked about group, it has to do with these things. These things form the basis of all properties of matter, and these are things that very few people know, and I think that these are things that everybody that's interested in how the world works or in the beauty of the world should know these things. Knowing these things makes it only more beautiful.
And was there a particular, say, concept that will from quantum mechanics that will kind of stick with you forever, either because it was the hardest or because it was the one that gave you the most insight?
Well, yes, the mechanism that gives things color, of course, but also this exclusion principle, the fact that these electrons are turning in orbitals around the nucleus, werking op afstand.
Well, the entanglement.
The entanglement, that one a measurement on one particle has an immediate effect on an entangled other particle. All these very strange, and Einstein would say these spooky phenomena. And yes, then you have the Bell inequalities. It's I have to say, it's something that I still do not understand, but I more or less I see it very vaguely. I think I understand what it's about, but it's just impossible for me to grasp it. And so when I hear Frank discussing with his colleagues, then it's very hardcore at a very high level. I'm sometimes a little bit jealous, and I wish I could participate, but I just don't have this mathematical brain. But nevertheless, I find it very fascinating that people, through this language of mathematics, they can go so far to the core of how nature works. I find it quite fascinating in the first time that people are able to understand all these things.
Yeah, and actually form the basis, because of this very theoretical understanding. They were able to build a complete new technology. All the technology, information technology that we use, like computers and lasers and MRI machines or atomic clocks needed for GPS, these would all be things that are would be completely impossible without a deep understanding of quantum mechanics. So big part of our current industry and technology is completely based on this very basic understanding of quantum mechanics. And the strange thing is, Céline already alluded to this, is that as a scientist, we really don't understand it very well yet. There's still many, many things in quantum physics that are extremely mysterious, that are completely open. And that's, of course, why there's so many researchers. As a researcher, once we understand something, it's not interesting anymore. But quantum mechanics remains so interesting because there's still so few things that we understand about it.
And you know, what I also found very intriguing is to notice that when we go back to 1925, because that's the reason why we are celebrating 100 years of quantum physics, is in 25, both Schrödinger and Heisenberg found independently from each other this fundamental theory, which opened many, many doors, but that these theories were so completely different, but at the end eventually led to the same conclusions. These theories were found in completely different ways by asking different questions using different mathematics, but eventually they are fundamentally comparable. And I find it, and also related to that should they not have found these theories, somebody else would have found it, because it's so fundamentally important. And that's something totally different as in art. Should War and Peace never have been written by Tolstoy, it would not have existed. Nobody else could have written it. But it's completely different as with theories, because it's wrong or it's right. In art, nothing is wrong or right. It's just a very personal interpretation. But what both worlds have in common, I mean, the artistic world and the more world of physics, is so that's what we have in common, Frank and me, that we both are very creative. If as a scientist you are not creative, you don't have original questions, you don't think out of the box, you will not get into the most interesting part, and that's very.
Yeah, it is very, very intriguing. For me, this was also very, very surprising how few differences there are in the creative process of doing physics or of writing a book. It's both of it is thinking out of the box, trying to find new ways of describing the same thing. And you try many things, and then suddenly you find something new and something interesting or something beautiful. So this is something that's completely underestimated, I think, for scientists, is that the creativity plays an extremely essential role. And I've had
there's a quest
many
for
students.
beauty as well, right? There is a
Yes,
quest
but
for
it's not
beauty.
just about beauty. It's just you feel it. It feels right. If you find something, you just feel that it's right because there is some inherent beauty in it, in the description of it. And but what I wanted to say is that I've had already many students, and it's extremely difficult to predict who will be the students that will be very good, or who will be the students that will maybe be good but not reach somehow the next level. And it's not because you have had always the best grades at university, at school, that you will be a good researcher. And that's something very confronting for students, is that they typically at universities, we don't develop enough this aspect that creativity is at the end the most important thing. Okay, that's what I see in all the great researchers. I have many colleagues that are fantastic. All of them have this sense of creativity, of always wanting to explore new things, trying to explain things in another way. This very creative way of looking at things. That's what most, let's say, very successful researchers have in common. And I think it's the same in any work that you do. It doesn't matter whether you're a writer or even a soccer player. It's at the end, it's the creativity that is the basis of everything.
And now, so this kind of creativity is something something that you have in common in both of what you do normally. Is there also something you've learned from each other? So something new that you have discovered that you weren't aware of before, whether it's about how you do things or the actual things that you do?
Yes, yeah, I have to say that I found it very useful to take a step back, and ask myself what is now really what are the defining moments in this whole theory of quantum physics. Because if you're a researcher like me, you're more and more specialized, and at some point you live in a very tiny world and you think this is the most important thing, but then you take a step back and see, no, there's a much bigger picture. The other thing that I found very inspiring is indeed this way of thinking about how can I explain this thing in more tangible ways. Because at the end, I think, well, I'm certainly not the first to say this, and this is also the title of our book, and the first one to really say this was Feynman. Nobody really understands quantum physics, okay, because it's so counterintuitive. It's very, very counterintuitive. The principles go very much against everything that we experience in our world. But nevertheless, we understand it because we develop an intuition for it. We understand it because we can connect this with many examples. We say, oh, this and connects to this and this and this. So there's some kind of an intuition that you develop, and that's how we do physics. But especially because of that, it's so important to be able to think in pictures, in terms of metaphors. And that's exactly what I think it's very useful to have these type of collaborations.
And Céline, is there something for you that you have learned that you weren't, I mean, apart from the quantum physics that you've learned, is there something about thinking about how you think about the world or how you do something that you've taken away from this?
Well, I have learned that even if you are not a master in, or even if you're not good in mathematics or in science, you are still able to grasp the essence and the basic ideas. So you don't think, of course, it's like in our book, there is still no mathematics. We don't use any formulas, only the very important ones. We wanted to mention them because they are so important. But even if without the mathematics, you can explain what it's about and how these ideas came about. And you can, and that's actually one of the main messages, that everybody is able to understand the basic ideas of it. The main reaction of people when you start talking about quantum physics is, too difficult, let it be, it's okay, whatever. But no, I understand this first reaction because it seems very difficult, but just take some time to do an effort and take your time to discover what it is actually about, and then you will discover that even if it is difficult, there is a very beautiful side in it, and it's really worth it to give it a try. It's the fact that something is difficult. Okay, people are climbing up the Mount Everest. That's also difficult, but at the end, that makes it so. That makes it worth the effort, and so why wouldn't? It's also the book. We hope that the book would be a kind of sort of an ambassador for young people who are still not sure of what they would like to study. That we want to open their eyes and to stimulate them from, look how beautiful this is. You just go for it. Also young girls, because there are so little girls who choose to study science. I don't know why. Yeah, for myself, I know why, because mathematically I'm not strong enough. But women are equally strong and good in science as men. So why wouldn't and it's just a conversation, the dialogue between younger and older generations, between male and female, that makes the debate so interesting.
And I was wondering, so now, Frank, you're one of the organizers of this current research program at the INI, which is called Quantum Field Theory with Boundaries, Impurities, and Defects. And Céline, obviously, you are there now, so you can kind of get some insight into how the Newton Institute works. And as an outsider, what impression do you get?
I'm very much charmed by the passion that these people are, the passion that drives them, and also by their integrity. And by the fact that all these people really work together. They have one main objective, is to find together to go to how do you say this, to come to new discoveries, and everybody has to help each other, otherwise you will not get there. Well, that's different from my artistic point of view. You make a play, you can perfectly do it alone because it's your personal interpretation of something, but in science you have to collaborate and you have to work further on things that had been discovered before you. And I find it very beautiful that you have all these discussions from morning till evening, till in the middle of the night. People are really working together, trying to come to new conclusions, and this relentless search for new discoveries. I found it very, very inspiring. And once again, I'm sometimes so sad that I cannot participate, but nevertheless, I can enjoy. I can just sit there for hours and listen to them discussing and talking in this language of mathematics. I found it very beautiful and inspiring as well.
And are you going to do something else? Are you going to write another book together?
Well, not together. Well, maybe together, maybe later on. But now currently I'm actually writing a children's book on the same topic, on quantum physics, because we noticed that maybe for some people, the book that we wrote now is maybe a little bit too difficult, and I want to step back and to see how we can make it even more accessible through an adventure book, through really from the age of 12, a book for all ages, but really trying to explain in a very playful way the essential things. And then afterwards, maybe something on quantum cryptography or something, things that are really very important in this current time. Yes, and then we will see. One thing leads to another. That makes it so nice. That's life.
That's it for today's podcast, and we will put links to everything discussed in the podcast in the show notes for the episode, including information about Frank and Celine's book called Why Nobody Understands Quantum Physics, and that book is published by Macmillan. If you've enjoyed listening to today's podcast, please do think about recommending us to a friend, or you could rate and review it wherever you're listening. It really helps people find us. Thanks for listening, and bye for now.